or with cybereum, just to let you know.
Cybereum. Yep. Cool. And we are on the live stream right now. I'm gonna start. Hi everyone. This is Chris from DoraHacks. Glad to host you guys today. This is the very first ETHDenver Virtual Hackathon project demo session. So for this year, it's actually the first DoraHacks that support ETHDenver for both in-person and virtual hackathon. And in the end, we have nearly 400 project submissions on both virtual and in-person one. So this is a pretty decent result, I would say. And so all the projects did a great job. And actually, we have three of them with us today. They are cybereum, AMHO, and also MetaMail. MetaMail. So without further ado, let's welcome the first team to start the presentation. And for all the audience, if you have any questions during the session, please feel free to ask in our YouTube chat room. Yeah, and Nath, feel free to start when you're ready.
All right, thank you, Chris. I guess my screen's still up, so that's good. Let me just try to maximize it. Just a second. Is that still visible?
Yeah, can you try to like move to the next slide to see?
Yeah.
Yeah, cool. Yeah, you
Okay.
can.
Great. So that's thank you again. So I've got two of my team members here, Chris, Christopher Cass and Geeta, who are also on the call. So there's three of us for cybereum. Now I'm going to spend a bit of time trying to introduce the use case, trying to introduce what we are doing, why we are doing it, and what architecture we are trying to build and how these are related. The reason is that this is actually quite different from, I would say, pretty much every other use case that you would have seen at ETHDenver, right? So we are basically looking at an enterprise platform, and what we are basically trying to do is that we are trying to allow networks of independent companies to collaborate and build projects. And by projects, we mean, mostly like real world projects, like construction engineering projects and so on, right? And this is based on a very acute kind of real world need. So essentially, we are trying to build a decentralized project management platform for autonomous entities. So it's kind of like a DAO for the corporate world. And there is a very good reason, why we are looking at decentralizing this, managing, these kind of projects, right? So to quickly kind of, introduce the type of projects we're talking about, we are talking about construction projects, engineering projects, large IT projects, and so on. Basically, these projects are the ones that affect our daily lives because, I mean, these projects result in the transportation, energy, and other infrastructure that has built the world around us and that support, I would say, essentially to support human civilization, right? And just to kind of review what projects are, and then I can go back to why, are we talking about decentralization of these projects, right? So this is the Project Management Institute's definition of a project. The PMI is, pretty, well known, especially with IT project managers. It is the largest project management association in the world. And this is a pretty well-known definition. So the three things to understand here. One is that it is a temporary endeavor. Why is it temporary? I mean, a project has a beginning and an end. It is something that is undertaken to deliver a certain result in a certain amount of time for a certain cost, and to deliver something that has been promised, for this, time and cost, right? And and as you get to the bigger projects, whether it's construction or IT or defense or any other sector, you are looking at networks of independent companies that are coming together for this temporary period of time. In academic literature, especially in project management literature, these are called meta organizations. Meta organizations essentially means, in literature, it means networks of independent organizations. So, when we're talking about decentralized autonomous organizations, in the business B2B world, I mean, there is already a term for these type of autonomous networks, right? And you find them in supply chain and in project management. In this case, we are talking about project management. The third thing about projects, I mean, they do result in some kind of unique and tangible value. whether it's, it could be a software project, or it could be, a building, or, a bridge, or anything of that sort. So essentially you have an autonomous network that comes together for a fixed period of time to create a fixed project, right? And the track record of projects, however, is quite bad, and this is actually related to the nature of projects, right, and the way they are governed. A lot of this data is from the Oxford Mega Projects database. As the first thing says, the first bullet says, if you look at mega projects, basically projects that are $1 billion and above, only 1 in 1,000 meets the forecast on time, budget, and scope, right? And if you look at any kind of project class, you find like this acute and this very severe kind of issue with project underperformance. IT projects are particularly bad, by the way, because you can see that average cost overruns for large IT projects is more than 100%, which is more than almost every other class of projects, except for maybe the Olympics or nuclear power plants. And just to kind of give, this is from our data. It just kind of shows the data from one type of projects. Essentially, the overrun for cost and schedule is on the x-axis. One, is 100% overrun. 2 is 200%. 3 is 300%, and so on. So what you see here is a non-normal distribution. This is not a bell curve. This is a fat tail curve with significant black swan outliers in terms of extreme overruns. And this is something that we observe across every class of project, right? So why is this the case? Just going back to the definition of projects, you have networks of independent companies that are coming together. You have contractors, subcontractors, vendors, banks that are financing it, promoters, governments, etc. And if you look at across every kind of contract in a project, and you're looking at hundreds of contracts linking so many different companies, right? Across every contract, you have a principal and an agent. The principal, basically pays or incentivizes the agent to do something for them, right? So every contractor is incentivized to quote the lowest cost and time, and overpromise on what they can do, the benefits, right? And they're also incentivized for their own sake to maximize their profit on the project and to stretch the time for as long as they can. So there is a fundamental misincentive. There's a fundamental conflict in incentivization across every one of these relationships. And that's what we call principal agent issues in organizational literature. The other issue is complexity. Complexity essentially, complexity theory essentially says that at different levels of hierarchy, given the more the number of interactions and so on, the more possibility you have for emergent issues. Emergent issues cannot be predicted as such, and that's what gives rise to black swans and dragon kings and so on. The extreme outliers that we saw in that chart. And this group network of these independent companies with misaligned incentives are not really good at reacting to these events because of the complex networks and the incentive misalignment, right? The other issue is cognitive issues, human cognitive issues. Humans are not very good at dealing with complexity. Humans also have a lot of issues with innate psychological issues where they have different types of biases. For instance, optimism bias is something that affects projects. Optimism bias essentially is something we're familiar with, everyday lives. We always underestimate the time that it takes to do something. We underestimate the cost that it takes, to do something, and so on. And this is again across every contractual boundary, right? And another thing to notice is when we're talking about networks of independent companies, all the schedules and the contracts are fractured. Everyone has their own individual picture of the schedule. Everyone has a contract with the counterparty, and none of these contracts and schedules are linked to each other in a way, that is, a trusted source of truth for the whole project, and doesn't update with the changes in the project either, right? So this is essentially what leads to project underperformance. And when we're talking about underperformance, we are talking about trillions of dollars of costs each year, because the project economy is tens of trillions of dollars a year, and it suffers from severe underperformance. So this is a massive economic issue. not only is it a massive economic issue, it's a social issue as well, because again, these projects deliver the infrastructure that support quality of life, that will create the energy projects that support the carbon, the energy transition, for instance. So this is quite a massive issue, right? Um, Now I'm just going to get into the architecture part. So I'm just going to jump to a paper that we have, um, to show what we are doing in order to resolve this and how Web3 will help, right? So when we are looking at a project, we look at a project at Cybereum as two networks, right? One is the project participant network, and then here we just go back to this, these meta organizations that I was talking about, right? I mean, these networks of independent entities. So that's the project participant network. The other network is the project milestone network, right? So a project is comprised of a set of milestones. And again, this is quite familiar, with for anyone who's done any project management course, because a PERT diagram, project review and evaluation technique, is where a project is basically shown as a network of activities connected by arrows, right? Essentially, is a DAG, a directed acyclic graph, right? So we've taken that fundamental nature of a project, and what we have done is that we have put smart contracts at the vertices, which are also at the project milestones, right? So each of these smart contracts would then essentially have the contract logic, and it would also have the schedule. So each of the smart contracts would identify what work needs to be done, who is responsible for doing the work, and what time that work needs to be done in, what are the rewards for completing that milestone, what is the verification protocol for verifying if that milestone has been achieved, right? And to give you a concrete example, of a milestone smart contract, the way that it is envisaged in this architecture. I'll just go back to a milestone, a project milestone. From my professional experience, I was a construction manager for an oil and gas company in Houston, and I was in Abu Dhabi taking delivery of a pressure vessel, right? So in order to take delivery of the vessel, we had to conduct a pressure vessel a pressure test. The vessel was pressurized, to 1.5 times the design pressure, and I was witnessing the test, as were two other people. The other two people, one of them was from an independent verification body. So this is like a third party that verifies if everything is done according to code, etc. And the fabrication yard manager, right? So the pressure vessel, passed the test, to no one's surprise. We all checked the gauge and everything else, and once that was done, there was a piece of paper saying that on this date, like someone had filled that the date in with a pen, obviously, and then we all signed, right? I mean, pen on paper. This was like faxed, or scanned and emailed back to each of our offices. Someone prints it out, sticks it in a file in these three places. So that means this milestone has been achieved, right? Now, how would you do that in a smart contract? If for this particular use case, that piece of paper could be a PDF or an electronic file of some kind that specifies what test was done. And once the smart contract determines if the three signatures are present, electronic signatures of mine and the other two parties, then it says that this milestone has been achieved. This smart contract has been executed, and if there is a payment to the fabricator that is due, that payment is then made to the fabricator, and the pressure vessel is taken. We take delivery of the pressure vessel, right? And each of these signatures is associated with the public keys of each of the companies that are involved, right? So this is kind of an example of a practical example of how this will be used. Another thing to note is that there is real value that is created in this network, right? So as each of the milestones is created, we are creating real value. Like if you're looking at a house, you create the foundation at milestone 1, you put in the windows or the wiring at 4 and 6 and so on, right? At each of these milestones, you're creating, it denotes the creation of actual value in the project. So we would be generating asset-backed tokens similar to NFTs to represent the value that's created. And at the end of the project, by the time the project is done, the entire project will be represented by these asset-backed tokens. And as each of the milestones is achieved, as the contractors are paid, the owner will take a delivery of the tokens that represent the asset in exchange for the payment to that contractor, right? So this will open up new ways of trading project-created value and funding them as well. Another thing to note is that these hundreds of contracts, independent fractured contracts in a project, are now linked together, right? And these smart contracts not only contain the contractual information, they're also linked to the schedule of activities and the timing and everything else that goes into the project. And if anything, like for milestone 1 might involve 2 or 3 different parties, and milestone 6 might involve completely separate parties who are responsible for their work. But if there is any change in milestone 1, quite often in real projects, the people who are responsible for milestone 6 don't really get to know of it in time. But here, because of the linking of all of these milestones, the information is autonomously propagated through the network. So if milestone 1 is delayed, then 4, 5, 6, 7, and the end milestone of the project will be affected and will be notified. You also have, in terms of decentralization, you also have the ability to verify commitments without requiring to have a central party that is a trusted party that keeps track of this, because every one of these milestones is written with a consensus of all the parties that are involved in that milestone. And it also, the smart contract also has the logic for identifying if work has been done. So again, all the commitments are verifiable, right? So this is the basic architecture. And essentially, as each smart contract is executed, that milestone is achieved, then we write out a corresponding block, and finally, when the entire project is done, then we put some kind of a zero knowledge proof, or for instance, a hash or something like that in a public blockchain, right? So that kind of allows me to get into this hybrid nature of this architecture, because we are looking at a public blockchain, for the final proof of a project, so that the project is always related to that hash, right? But at the same time, the project network itself is a permission network. I mean, and again, we have to remember that this is a business-to-business enterprise use case. You need to know who your counterparties are, and you also need to keep a project, right? I mean, which is essentially a commercial undertaking, as a permission network to the parties that can access it, right? So that also brings us back to this diagram here. So we have also been looking at different ways of authenticating project participants, and we were looking at building a project PKI, a platform PKI of sorts, essentially a PKI implementation for the blockchain, right? And we have actually scrapped that recently. That's one of the things that we were trying to build, and that's one of the things that we just completely revisited, because we were trying to do something like this, and we had started building a PKI on AWS. Excuse my lighting. Screen just went off. Okay, so we were kind of going down that path, and in the last few weeks, we have just completely reconceptualized that as a DAO. Basically, like each of the verified credentials, would be issued by a DAO for that particular use case. The rules for verifying identities and the governance will be related to the governance tokens on the DAO and so on. So essentially, this is something that is still, the implementation is still evolving, because some of the bits and pieces to realize this architecture are still not there. However, we have conceptually proved a lot of the elements of this architecture at a more fundamental level. This, for instance, is a offshore oil and gas project that I had managed at some time, and these are the approximately 200 high-level milestones. So what we did is we have an algorithm that basically read in the project schedule from Oracle's P6 software, which is a project management software, and it wrote it out, as a hash link network, right? So if you look at, by the way, just to explain this, every one of these activities is related to the project and is connected with each other. And the beginning milestone is here, the ending milestone is here. The size of these circles is related to the degree centrality, the number of activities that is connected to that, that particular milestone. This is the shortest distance, and because the length of the arrows is proportional to the length of the activity, we did D3, using JavaScript to generate this graph, right? So every arrow that you see here connects this to this. The shortest arrows go more or less directly, but the longer ones go, the critical path, for instance, loops all the way around. But another thing to note is that every one of these milestones contains the hash of the preceding milestone. So we essentially have proven the concept of making these complex schedules into these DAG hash link DAGs, right? So we've built out the we were also starting to build out a wallet using Python PyQt5 to allow people to interact with each other, and visualize the project progress and so on. But now we are kind of completely revisiting that, because I think we're looking at web-based wallets, and we are looking at more of a web-based app rather than having a completely separate application that we are programming, right? So anyway, that's kind of the architecture, and that's where we are. And some of the things that we were doing, we have completely gone back to the drawing board, especially after ETHDenver and interacting with some of the projects, because there are some things that we probably don't have to build from the ground up, and which we can probably work with some of the projects on, right? So I'll just pause here and see if there's any questions.
So I don't actually have many questions, but just want to know that it's already 20 minutes, so just try to summarize everything like in 1 minute. That'd be great. Yeah.
Okay, so I'll just kind of quickly, in one sentence, try to say what we are doing to summarize, right? So we are enabling autonomous networks of independent companies to collaborate effectively and plan and build complex projects, and to tokenize the value that is created in this project. So that's essentially what we are doing, and all of the things that I presented is related to that.
Got it. Yeah. Thank you very much for the presentation, and also thanks for all your team that show up here. It is a pleasure to host you guys today. So personally, I cannot give too much, comments or questions about the project, because it's kind of a little bit too hardcore for me to understand like the whole concept in this short time. But I do believe that it is quite a unique cutting point about the whole Web3 ecosystems, especially when the whole infrastructure right now is not that completed yet.
Yeah.
But as you said, there are already many of the thesis has been proven, and me and our team do really looking forward to see how it goes about the industry and also about your project in the future.
All right, thank you, Chris.
Yep. Thank you very much, Nath, and also the whole cybereum team. And we're gonna move to the next project, which is the AMHO. And feel free to start when you're ready.
Yeah, sure. Let me just share my screen. Then wait till it comes up, and let me know if you can see if this presents on full screen.
Yep, I can see.
Can you see it now?
Yep.
Okay, great. Yeah, hi everybody. So we're AMHO, and AMHO stands for hidden in Korean, or it stands for password or crypto. So what better name than AMHO. So we're essentially a dApp marketplace that creates physical items and digital NFTs tethered to those physical items. And this has actually been a problem that I've been dwelling on for a long time, but I haven't had a chance to actually build it until I got to ETHDenver. And ETHDenver is essentially the time that I can use to essentially bootstrap this dApp marketplace. So just some background, we are essentially trying to show what luxury fashion can look like in Web3 and crypto in general. And the inspiration from AMHO was essentially from Unisocks, which was an item that follows a bonding curve that was started by the Uniswap team. And it was pretty much a project where you're able to buy a token that you burn. And when burning that token, you essentially get to redeem that token for a cotton sock. But the problem that is exemplified here is you're paying, the current price of Unisocks is about $80,000 USD to $90,000 USD as of today. And you're paying for essentially a token that gives you a cotton sock. And immediately I saw that as an issue. At AMHO, we really want to build luxury items for the metaverse and physical items that have artistical value alongside with it, along with the digital NFT that also has artistical value. Also, second inspiration from this was from The Fabricant. And in 2017, they created this kind of AR digital NFT item, and it kind of gave rise to the birth of digital fashion and digital fashion in Web3 and crypto. But the problem between these two projects is one project focuses entirely on building a physical product or a tokenized physical product, but the product is cotton sock. And then for The Fabricant, they're very maximalized on the idea that we are going to live in a world where we'll 100% wear clothing like in games, digital clothing like in games, etc. And they actually don't make any physical items. So AMHO is really a means to bridge these two things together, but doing it in a decentralized and secure way. And so there's three actors to our system. There's the creator of the item, the factory or the fashion house or whatever party that creates the physical item along with the digital item. You have the seller. In this case, the seller can be the creator or the factory. And then you have the buyer. And in terms of a decentralized system, you have to ensure that, like let's say you sell an item on the marketplace and you want that item to not be burned. You want it to actually have that, you want the buyer to essentially have the digital NFT along with the physical item that comes with it. So how are we supposed to tether this physical item to the digital NFT? And that's essentially something that I'm trying to solve here. So what we built is a creator experience to create a QR code for digital items or physical items with the digital NFT. There's an NFT tethering mechanism that is utilized in my system to essentially tether the physical item to the digital item and only allow certain parties to be able to decrypt that QR code. Problem I saw with QR codes in the early days, it's mostly used for a read function. Like it's mostly used to, like, let's say you see a QR code on an item, but you scan it, but it just goes to like the Etherscan address or wherever the IPFS node is hosting the item. There's actually not much utility that you can use with a read-only QR code. So in this case, I'm actually using the QR code to open up functionality within our smart contracts and only allow the buyer and the seller to open that functionality up, decrypt the code on the smart contract, and utilize that secret code to execute function calls. But the thing is here is you don't want that QR code to essentially, my background is in cybersecurity. So you essentially don't want that QR code to be scanned by a bad actor or malicious actor, where it's like, let's say you buy an item from a creator or a factory, and then someone comes up and just scans your QR code and they took your digital NFT and they mug you and take the physical item. Like we don't, like I built this application with bad actors in mind. So the QR code is essentially utilizing lit protocol with ceramic, where ceramic's a storage layer. And the QR code isn't just the ceramic stream, but nobody besides the buyer and the seller is able to decrypt that ceramic stream unless you are the buyer or the seller, according to the mapping in our smart contract. So, I mean, lit protocol was really like the last piece of this puzzle. And I've been looking for something like that for a long time. And this is an application that utilizes that mechanism. We also have on-chain ownership and validation of tethering. And we also have an Oracle mechanism to mark bad actors. I wasn't able to build the Oracle within the front end just due to the constraints of time, but essentially an Oracle that, what happens if a bad actor, again, like decides to just sell the NFT on a secondary marketplace or a tertiary marketplace, or the person with the physical item and luxury good decides to sell it on StockX or something like that. In terms of forcing both those parties to use our dApp marketplace and tether these items on our dApp marketplace, we have to build value in our dApp marketplace. I kind of see it like this. You have the physical item, which is kind of like a lock, right? And you have the digital item, the digital NFT, that's kind of like a key. You need both to be able to use it in our system. You need both to, whether it's like for an airdrop or a Discord link or a community, you have to have the tethered item. And if you don't have the tethered item, the Oracle will see it, untether your item, and in that case, the lock and key are separated, then it's just a physical good. Then it's just an NFT. That value is no longer used in our system, and it's pretty much just useless. So we want to combine these two things to unlock that value. So here's kind of like the demo flow. I'll actually just show you. Let me just make sure I'm logged into MetaMask. And let me just make sure I'm logged into MetaMask on the side. So on one end, on the left side of the screen, you have the seller. On the right side of the screen, you have the buyer. So this interaction starts at the seller, and the seller is going to be the creator and the factory in this place, or the fashion house. And let's say they create a digital NFT that they decide to sell on their marketplace. So let me just choose a file, and we'll choose this beautiful rendered 3D item, and then we'll decide to mint it. And then during this minting phase, this is when we send one link to the Chainlink VRF. So we get that random code that we can use for a QR code. We encrypt it using lit protocol, and that ceramic stream is encoded into a QR code that we can possibly put on this physical item that we make. So let's send this link, and we'll wait for gas. So we'll wait for this confirmation to happen. And since it's a VRF, it's going to poll for a random number. But if the node doesn't pick up, our hash and give us a random number in time, it will possibly error out. But luckily, we have time to essentially try it again. So just fair warning: if you see a thrown error, it's usually because the VRF didn't give us a random number in time. So this might be a 2-time thing, but hopefully we get it the first try. And if we get it the first try, there would be no error, and a QR code would be generated right here. So we'll just wait for that to confirm, and get the random number just executed. So it's gonna essentially wait for the transaction to go through, and once that transaction goes through, we'll wait to get that random code that we use for our QR code. This might take a while. I see like 20 to 30 seconds. I set the timeout as. So let's see. Great. So first time around, like we got that random number and it generated a beautiful QR code for us. So just imagine that this QR code is just on the physical item, right? So we'll save this QR code in a new tab so we can use it for later. And so the transaction I just sent is actually a minted. It just minted the NFT. So I believe if we go to the eShop, it'll show that that item's for sale. So on the buyer screen, now it's the buyer's turn to do something. This sees that this factory made this beautiful digital NFT, and I want that digital NFT and I want the physical item as well. So let's click on it and let's buy it as a buyer. And notice that our little profiles are bufficorns. Like we have the bufficorn seller, bufficorn buyer, and we're using Ceramic's basic profile DID to get that profile, to get that name, and to get that DID. So let's buy it on the buyer side, confirm, and approve the contract to allow it to spend the funds. And then it's going to send another transaction to actually send the funds to the smart contract. And there's an escrow smart contract that holds the funds on behalf of the buyer and on behalf of the seller. So we'll wait for that to go through. There's going to be another transaction that fires. And then this is the transaction that essentially sends it to the smart contract, the escrow smart contract. Great. So it sent it to the escrow smart contract. So now like we should have an updated view on the buyer showing that we're essentially waiting for an order. And notice here that, there's an order that's waiting, we're essentially waiting for the seller to do something. So in this case, the seller essentially gets notified. Like we go to the collections of the seller and it sees that, oh, an order just came, and you kind of see this like QR code that, the seller needs to scan. So in between the seller scanning the QR code to when the item is created, let's say that, this launches the production of the item. So, we see an order come in, and now the factory or the fashion house is actually going to make that physical item. And we have the QR code. So they put that QR code on that physical item, and that's a way for it to tether. So let me actually show you this in my phone. So I'm actually logged in as a seller on my phone, and we are going to scan that QR code right here that we just generated. So let me go to collections. Then it shows that I have QR code to scan. Great. So using a mobile device, I kind of thought of like the novice user and why it's important to make it easy for individuals to use this system. So the moment I click on scan QR code, you see a QR code scanner, and we scan it. And in our smart contract, it actually verifies that we're the seller of this item. And if we're the seller of this item, we actually get to decrypt that ceramic stream that has that secret code that we utilize in our smart contract to unlock that functionality of initializing this item for shipment. So let me send that transaction on my phone, and we'll wait for it to confirm. The transaction just submitted, as you can see. And now we are going to wait for confirmation. It's going to take a second. And for this case, we are using the Polygon network. Okay, the transaction just completed. So now, the transaction completed. The seller created the item. They scanned the QR code, and now there's going to be an off-chain interaction between the seller and the buyer to send the shipping information, etc. If we can decentralize a shipment, that'd be great. That is a problem that hasn't been solved yet. So now, like it's the buyer's turn to do something. The item gets shipped to the buyer. They receive that item, and now they scan the QR code on the item to essentially tether it to them. So if we go to the buyer screen and kind of reload this collections page again, we'll now see a different black QR code on the buyer saying like, hey, I actually received this item, and let me just show you, like we actually have this physical item made. Like it's in buffalo leather, and it was made by my extremely talented partner, who's a fashion designer for Stuart Weitzman. So so that's great. And so let me log into the buyer account, and let me start this QR code scanning mechanism. So the buyer account, you see the black QR code. And let's go back to our QR code we saved. But imagine this QR code is on the physical item. We scan it, and we start that process again. Sign to log into Ceramic with Lit. And then we send the transaction. Now, Lit sees that QR code. It pulls that data from that ceramic stream and pretty much calls to the smart contract saying, is this the buyer sending this message? Is this a seller sending this message? If it is, it allows them to execute a function to change the status of this NFT item. And now, if we go to the buyer screen and go to collections again, we'll see that we owned it. So that's entirely the most basic MVP of the system I can make. But this is a really important project to me, and we want to show how hybrid fashion, metaphysical fashion can be done in this niche that we're in, and to show how to make actual quality and luxury products. So we're essentially starting with leather goods, but you can imagine from the investor point of view, anything that you can put a QR code on, we can essentially utilize. So for the intent and purpose of that, that's my entire application. Thank you so much for listening to me ramble and listening to this very complicated system, but I poured my heart and soul into making this application. So thank you.
Yeah, thank you very much for the presentation. And I do really see that you are passionate about this, what you guys are trying to do right now. And a few questions from me. The first one is, do you guys have any future roadmap that wants to share here?
Yes. So it's kind of like a light roadmap. So I'll just share my screen again.
Yep.
and we'll just stick it to a window. So if you go to our website, amho.xyz, kind of see our like mini roadmap, and this is the AMHO project. We're a community-driven design house for designers, creators, technologists building luxury physical goods that can interoperate with Web3 and the metaverse. The items that we make will essentially be tokenized on chain, and those 3D items, our goal is to interoperate with every metaverse out there, or wait for a specification to come out that ties all those metaverses together. So kind of waiting for certain things here and waiting for how this industry is going to evolve. But the vision here is we essentially want to be a Web3 fashion house where decisions are decided by our community members. We want to be community driven first. And the collection we'll drop will consist of luxury garments and accessories designed to have its own identity and utility within our ecosystem. Some future alpha here, like we might want to run a fashion show based on the goods that we make. And we have experience running fashion shows as well. Our team is put together. We have the factory to, yep, go ahead.
No, I didn't.
Okay. Yeah. So we have the factory, the leather goods factory to actually make the goods. We have the leather supplier to supply us that leather, and all the leather is actually sourced from kind of like the discards of the meat industry. So this is a very green way of doing it, where it's like, yes, we want to make physical goods, we want to make luxury goods. They need to be scarce, but we want to do it in a way where we care about the environment, because blockchain in general is very impactful of the environment, and that's why we kind of decided to go this way. So the collection that we'll drop will, so again, we're blockchain agnostic. We don't believe in maximalism and in one chain. Interoperability is key in this space, and I feel like that's going to be the next frontier. But we're not tied to one, but to all of them. And our first collection will be developed on Polygon for the sake of its cheap gas and its architecture. But our future collections will be released on other chains. So all this is in stealth right now. So, I mean, the first project is kind of a beta test. Like that's this phase right now, going to making the prototype that I just showed you and making this dApp marketplace for ETHDenver. Like that's the beta test. But after that, we're essentially going to make one of ones to order and utilizing this dApp marketplace. And our next collection and our kind of like our third like phase is going to be generative. That's all I'm going to say. Like, I'm not going to say much about that. But I mean, people that's been in this space could kind of see where that might go. And then after that, like once we have like the name and the brand and the network effects, like we're essentially going to launch the spring, summer, and fall, winter collection and have that kind of build out that fashion house kind of with spring, summer, and fall, winter. So that's essentially like our light roadmap. Like I said, again, we're essentially in stealth, but we're going to build this thing, and we have the entire production team to do so, along with the designer and photographer, videographer, and marketer, and also myself as a web application, Web3 application developer.
Got it. Yeah, that makes sense. And also, just let you know that DoraHacks is also a multi-chain believer. We host multiple different chain grants and hackathons to our platform. So feel free to check out if there are anything that you might be interested in the future. Right now we have Solana and Avalanche, and in the future we're gonna have Harmony and probably Polygon hackathon in May. So feel free to join the hackathons and get more exposure in front of the ecosystem devs communities and yeah. And another questions will be, so you just mentioned like so the whole project gonna be more like community centric. So but one of the problem that I just thinking of is so like community flavor gonna have different with the creator or the designer flavor. So like designer want to produce some wearables and goods that might not fit the community's demands. So how do you think you're gonna like balance that difference?
Well, I think in a large sense, that is not just a specific project problem, that's a specific DAO problem. And a lot of DAOs actually struggle with this consensus between like their community and the things that they want to do. And I know that Gnosis, the Zodiac team from Gnosis is trying to tackle this problem with DAOs and create DAO patterns. So definitely check out what Zodiac's been doing. So I think DAOs are an exciting thing, but it's a very hard thing to get right. Because you're essentially turning an entire company into a decentralized entity, and you're trying to make everybody happy at the same time. But in terms of like the people that don't mend well with our vision or mend well with our proposals that we set out in our community, then those are essentially the type of people that we don't want in our community. We want people that love fashion for the history and love the goods that we make, and to respect our decisions and design decisions that we have as a fashion house. So I think, like I said, like those people aren't the people that we want. And I think but it is a very big DAO problem that a lot of DAOs struggle with, is their community and aligning and having people participate in proposals and having teams execute on those proposals. And I can imagine as a fashion house of Web3 run on the community, we're going to cross those problems. But as those problems come to us, we'll treat it like, a startup. We'll iterate and we'll communicate and we'll be transparent.
Got it. Yeah. Yeah, that's pretty much every questions that I have. Thanks for the presentation and the demo show. This is really detailed and helpful to understanding what you guys are trying to build. Appreciate your time. Yeah, thanks a lot. And we're gonna move to the next project, which is the MetaMail. And Sanel, feel free to start. Ready?
Hi, everyone. Can you see it?
Hi. Yeah.
Hello?
We can see.
Okay. Thank you. Hi, everyone. I'm glad here to introduce MetaMail here. I am Sunil, and we have 3 members in our team. I'm the backend developer of MetaMail. Joy is the front-end developer of MetaMail, and Molian is the designer. So what is MetaMail? MetaMail is the Web3 email provider. With MetaMail, users can use their wallet or ENS as email address, and they can use their wallet to sign, encrypt, decrypt the email to ensure the security. For example, I can use the sunil.eth at mail.inc as my email address, which is the same address as I registered in ENS. It's very simple. If a user don't have an ENS link, they can use their wallet address as their email address. And all these features are free. They are free to send and receive with users of our mailbox, as well as other common mainstream mailbox. Secondly, users in MetaMail can sign every email they send. When they click the send, they need to sign the total mail with their private key, and the recipient will be able to verify the mail to see if the mail is modified. Third, with MetaMail, users can encrypt their email with PGP encryption. When sending the mail, the sender can encrypt the email with the receiver's public key, and this ensures only the receiver can encrypt the email with their private key. So this ensures the ultimate security. These are the 3 highlights of MetaMail. And why we build MetaMail? Well, email has been invented for over 50 years, but nowadays most emails are still in plain text. They are not signed or encrypted or decrypted. Some technologies, such as PGP mails, can encrypt mail, but they are not popular among everyday people. Why? Because most users users don't want to maintain their private key or public keys, which is essential for signing and decrypting. Well, with Web3, everything has changed because every user in Web3 will have their private key and they have public key. They have address and they can register EMS. So when users use their address for EMS as their email address, they can there are always private keys behind that, so they can use the keys to encrypt, sign, and decrypt their email. This, this keeps the email secure. So let me just show our application. Let me share my screen. Okay. Okay. This is MetaMail, our website, and users can just click the client wallet. Click the little sign to log in. Okay, we just log in, and this shows the user's email. For example, this is the email from Facebook. And in the right corner, this shows the user's email address with ENS or wallet address. So users can write email, for example. I just send an email to myself. For sending, I need to sign as a plate, and I need to sign my email. The sign content contains the sender, receiver, and the content hash. Just click sign. Oh. And oh, there's something wrong. And normal email just shows like this, and there is a logo shows that this email is signed and verified. Yes. Okay. Okay, go back to the slide. Okay. So MetaMail is in beta now. You can, if you register now and send or receive email, you have a chance to get our NFTs. And that's all. Thanks for listening.
Yeah, got it. Thank you very much for the presentation. It is absolutely a very cool functions to bring the email to a more decentralized Web3 way. One question from me is that so like when users are trying to send email, they need to sign the email, and do they need to pay for the gas fee?
Gas fee?
Yeah, when consumers trying to send the email.
Oh no, they are totally free, and they don't need to pay any gas fee because their email are not on blockchain. They just signed or encrypted to our server, and we will send it to our other email servers like Gmail and Yahoo like that. The email content is not unchanged because if they are already encrypted with their private key, then the content is totally secure.
Okay,
So,
got it. Yeah. And also another question is, I assume that you guys are trying to build this project as a startup. So, what's your revenue model looks like? So, like, how do you generate revenue from the project?
generate revenue. We just start this application in a few weeks. So I think in the future we can add some advertisement in our website to keep profit. Yeah.
Got it. Yeah. Thank you very much for the presentation. It's a very interesting project for sure. Yeah.
Thank you.
Yeah. And I guess that's it for today. Thank you guys, all three wonderful team to join us for the first ETHDenver virtual hackathon. This is a very interesting demo session. For sorry, okay, yeah, that'd be great. Yeah, I believe this demo session is really interesting. All three team has some really cool functions to revolutionize the traditional way revolutionize somehow the traditional way that we live, like the email or the fashion or the project management. So yeah, I believe this is really helpful to understand that what these three teams are trying to build right now and also in the future. Yeah, I guess that's it for today. Really appreciate your participating and time that contributed to this demo session, and hope you guys all doing great in the future, and try to develop the next Kickstarter superstar product in the future. Yeah. Thank you guys very much, and see you soon. Have a good one.